So yeah, I'll be. Oh, okay. So my screen is visible, right? And you guys can hear me clearly?
Yep.
Okay, good. So yeah, I'll be presenting chemical engineering department. And so a little bit about myself. So I'm gonna go through my CV quickly because I was a bit lazy to put the information to the PPT. So yeah, I'm double majoring in chemical and biomolecular engineering and computer science, and also advanced major in chemical engineering. So I was lucky enough to be involved in a publication. I think half a year ago or a year ago, yeah. And I was also involved in a couple of more projects, like other people's projects and my own projects. And so I joined this lab under Professor Jafer Yavuz in February 2019. I had just finished my first semester when I joined the lab. So I was lucky to get accepted. And so I very briefly worked on nanomaterials. I'm sure some of you have heard of the nanomaterials. And so I worked on carbon dioxide capture and conversion. That was one of my projects, which was published. And then I did like 4 or 5 different projects total. And then very briefly, one of them was lithium sulfide battery. So the conventional battery is lithium ion, right? So we tried to replace cobalt in a battery with sulfur. And then other projects involved like precious metal capture, like gold, platinum from the bottom of the ocean, right? So that was also quite cool. And then I did a project related to pure chemistry as well. So I spent like 1.5 years in this lab, and yeah, hopefully these will be published soon. So recently, like previous winter, I did an internship in a company called Yusong in R&D department, and then overseas sales. So I did marketing as well. That was also quite interesting. And recently, like this March, I took a 180-degree turn and decided to do an internship in coding. So to be specific, in Professor Juho Kim's lab, I joined as a backend developer. I'm actually now in the lab. So the project is to build a mobile application for foreigners in Korea to teach them basic Korean. So my job is backend. And for those of you who don't know what backend is, it's what is it? The part of the application that you don't see that is actually happening beneath the front end. So it's like server and yeah. And then I wasn't quite sure if I should include this, but yeah, this is like the plan. I got an offer from the Columbia University for an internship this summer. So yeah, this summer, hopefully I'll be in Columbia. And the topic is solar fuels engineering lab. So I'll be, I was quite lucky actually with the project. So it combines a lot of topics that quite interest me, which are carbon dioxide capture and conversion, and then reactor design. That's a very cool topic actually. And that's like hardcore chemical engineering concept, like reactor design. And then I'll be doing modeling, which is also one of the very famous fields in chemical engineering. So I'm really looking forward to this one. And then yeah, like a little bit about extracurriculars, I guess. So yeah, besides the academia, like I was involved in a couple of events and stuff. Like I opened a volleyball club. So if any of you is interested in volleyball, like as soon as the sports complex opens, I will be running the club. So anyone is welcome to join. So yeah, that's, I guess, very briefly about myself. And um, so yeah, let's continue. All right, so why major in chemical engineering, right? That's, I guess, a main question. And personally, I could, after talking to a lot of people in chemical engineering who, and then thinking about it myself, I was able to divide those reasons into two categories, right? So one is, and I think I'm also partially in this first category as well, which is money and job opportunities, right? In chemical engineering, since it's an engineering field, it is almost guaranteed that there will be money involved and then good job opportunities, right? But what exactly are we talking about here, right? So when we say money, what is the amount? And when we say opportunities, what are those opportunities, right? Um, so I would say if you're in this first category, and then if you're 100% sure, like if your motivation is like 100% in this first category, which is money and job opportunities, and if you are okay with achieving that aim with any means, right? Um, which means you don't mind majoring in any field, then I would suggest you to go to CS, AI, or data science, and not chemical engineering. But you have to make sure that that's the case, that you're 100% sure that you're in this first category. If not, then yeah, I hope the rest of the talk will prove helpful to you. And then the second category is some of the reasons could be like genuine interest or passion in chemical engineering, right? Which is a bit hard as I believe a freshman because I'm guessing you didn't experience much chemical engineering yet. So another reason could be I have no clue like what is chemical engineering, right? I just want to maybe try it. Um, and then, for example, personally, I was in this last category mainly. I was a bit good at chemistry, but I didn't want to get stuck in the lab, right? So I thought like chemists are like they spend their entire life in a lab, so which wasn't really attractive. So yeah, I was both like a little bit in the first category and then second. So I decided to go with chemical engineering. So yeah, I'll tell the details of each category in detail, hopefully, in the next couple slides. So yeah, let's compare chemical engineering versus chemistry and material science, right? So because as far as I know, those two departments, like chemistry and material science, are closest to chemical engineering, and people usually find it hard to differentiate between them, like especially, I guess, in terms of the industry. So, but before that, a little bit of history and origin of chemical engineering. So it's a relatively new field. And I say relatively new, but it started like a century ago. But then I say new because like industrial revolution started almost like 300 years ago. But then chemical engineering was introduced relatively recently. And the reason was the First World War and mainly Second World. So after the Second War, the field of petrochemistry came into the light, and then it was a hot topic at the time, right? So, and petrochemistry is converting petroleum to other, what is it, daily, what is it, utilized, should I say, chemicals or materials such as plastics, like clothes, almost majority of things you see around yourself is because of petrochemistry. Plastics are everywhere, right? So, so what is the difference between chemistry and chemical engineering? Chemists, as far as I know, do not concern themselves with uh, what they are producing. Like if the product they are receiving has any practicality in the market, right? In the industry. So if you go to a chemist and then ask them why did they synthesize a chemical, if it is useful, if it is scalable, if it has good economy behind it, they will probably won't be able to answer you because chemistry, as any other science, is just exploring or discovering science, right? But how is it different from material science? Material science is as far as I know, it's in between chemistry and chemical engineering. So material scientists care about what they work with, but then they don't care much about scaling it up. So they care about obtaining useful products, but then they're not concerned with bringing it to the market and then scaling up, like, where is it? Building reactors, right? So chemical engineering is essentially a continuation of chemistry and material science, right? So chemists and material scientists design useful products, and then chemical engineers bring it to the market, bring it to the industry. So they scale up reactions, because in the labs, as you know, reactions happen in like 50 milliliter flasks and stuff, right? So when you scale it up to a couple of hundreds of liters, couple of thousands of liters, there is a whole field which is called chemical engineering. And then there is not much chemistry involved in scaling up, actually. Scaling up is mainly math and physics, unfortunately, for some of you, I guess. So this is a very basic schematic of what chemical engineers do. So you learn thermodynamics, kinetics, mass transfer, heat transfer, fluid flow. So these 5 concepts are the cornerstones of chemical engineering. So if you're good at those fields, you can design a chemical reactor. And then, yeah, like other minor fields as well, like mathematics. I mean, I shouldn't say minor, but yeah, process control, design, economics is a very important aspect uh, in chemical engineering. And then eventually it leads to money, right? So since chemical engineers directly deal with the market, with the industry, they get paid relatively a lot. As far as I know, like compared to chemists, or I'm not sure about material scientists, but definitely compared to chemistry. Like engineering almost always gets paid a lot compared to science, unfortunately. So yeah, that's very briefly about chemical engineering. So yeah, like what career tracks you can pursue in chemical engineering? As far as I know, there are 2 very major categories. One is academia and the other one is industry. So if you go to academia, if you want to go to academia, which means you want to eventually become a professor, right? That's what I mean by academia. So yeah, as an undergrad, what you can do is probably have publications, which is quite challenging but doable. I can talk about this a bit more if you guys want to, like in a Q&A session, and then have strong letters of recommendation, right? Because you want to get accepted to top schools, and then have a good GPA. So yeah, you apply to top schools, top programs like PhD, masters, and then hopefully find a good mentor, and then continue along that path, right? After that comes postdoc, and then I'm not quite sure, but yeah, there are a couple of steps until becoming an assistant professor. So what about the money in academia? It's actually, it varies a lot actually. Just a second, I think I'm receiving. Questions right now. Okay, all right. So yeah, the money is it varies a lot actually. It's hard to say like people in academia receive this much, but I can give you a couple of numbers from experience and from what I know and from what I found on the internet. So a friend of mine who knows a great deal about professors and their salaries at KAIST told me that the best CB professors at KAIST earn less than 100,000. I think it was in 100 million, right? Around $100,000 per year, which is Actually, quite good amount of money for Korea. But that's the best professors. And then I heard it varies from 50 to 100. Like 50 is it's not so good for a professor, right? But then, for example, my mentor, like Professor Jaffer, who actually left KAIST recently and now is a professor at KAUST. It's in Saudi Arabia. He receives over $500,000 per year. So that's actually quite a good amount of money. Like Saudi Arabia, as you know, is a rich country, so that's possible. But his mentor, like my mentor's mentor, receives, for example, over $1 million per year. But that's a special case because he has a Nobel Prize. So Nobel Prize winners earn as at least as that amount of. So my point is, it really changes from place to place, where you are, which university are you, and then how much experience you have, how good you are. Like there are a lot of points to take into account. But overall, being a professor is not. I mean, if you're after money, like for example, I am, becoming a professor, it might not be a good, what is it, choice. So you might want to go to industry, but then after having your bachelor's degree, it's hard to go to industry and then start earning good amount of money. I have a friend who graduated from MIT recently, and he went to the best there's a chemical engineering company you can imagine, which is Saudi Arabia, a petroleum company in the US. So he started earning around 50,000 per year in there's a Texas state. That was okay, but since he graduated from MIT with chemical engineering degree, one would expect him to earn a bit more than that, right? For example, like CS students, on average, and I'm talking about average in the US earn around 70,000 or so. So yeah, uh, but then so what you want to do if you want to go to industry is having a PhD degree helps a lot. Like I have another friend who also works in the US in Saudi Aramco who got his PhD at KAIST, but he earns over 100,000 per year. It's like twice as much difference. That's the starting salary, right? So that's the difference you make with a PhD degree. But you want to make sure, like I'm just giving you one example that it probably depends from company to company and then position to position, right? And then how much difference you're gonna have if you have a PhD, and then how much are you losing if you don't? So you want to you want to do your homework before you go and pursue that 5 years of PhD, right? So industry actually consists of, I think if you go to industry, you can do three things. One is you can become a researcher in the R&D department. So both of my friends at Saudi Aramco, for example, are in the R&D. And then you can go to the design team, which, as far as I know, they maintain the reactors. So, like designing a new reactor is almost out of question because it doesn't happen every day. Like once you design a reactor, it just stays for decades, right? And because it's not an easy job, like it requires millions, if not billions, of dollars of funding. So I know if that kind of job interests you, yeah, that's one option. But then you can go up to management section from R&D and design, right? Management, you won't do any experiments, you won't do any engineering, you'll just like manage teams of engineers, right? But then that pays a lot. That relatively pays a lot of money. So yeah, I just what is it? Googled found a couple of numbers. I don't know how much they're reliable, but yeah, they're pretty much close to what I expected. Like so as you can see, on average, like chemical engineers, and this is the median value average, is around like $70,000 per year in the US. That's actually kind of good amount of money, I would say, as a starting. If you compare it to CS students, they also earn around the same. But then, like, I guess it wouldn't be smart to overgeneralize it. As I said, like a friend of mine from MIT started from 50. So yeah, again, like you want to do your homework before you plan, right? So yeah, this is about like very briefly about the career tracks, and there are, I guess, a lot of other things you can do. One is startup, for example, which I'm interested in. But if I go to that direction, I guess I'll talk a couple more hours. So yeah, with that, let's go to the next slide. In terms of coursework, to be honest, I'm actually not a great fan of coursework. It's just, I know, like a lot of homeworks and attendance and all that stuff. Quite boring for me. But um, one advice I can give you about coursework is there are, as I mentioned before, like cornerstone courses as a chemical engineer. Like if you really want to call yourself a chemical engineer, if you really want to become a chemical engineer who understands basic principles of reactor design and maintaining and designing a reactor, these four courses are fundamental, like thermodynamics, reaction engineering, fluid mechanics, heat and molecular transfer. So the last three courses are advanced courses. So I don't know why KAIST actually labeled them as advanced, but even when you go apply to graduate school, these courses are mandatory in the US, for example, in the West. So they will ask you for these courses. As a chemical engineer, you need to, like, you have to have these courses in your transcript, as far as I know. For example, a friend of mine who is currently doing a PhD at Cambridge told me that when he applied to MIT for a PhD, his interviewers, professors at MIT, asked him why he had low grade in these courses. So, which is a tough question, right? Um, so yeah, you want to make sure that you take these courses. All right then. So yeah, one advice I would like to give you is plan and start executing early. That's what I did back when I was a freshman. I joined the lab after my first semester. And yeah, so and it's okay not to know what you want. Like when I joined the lab, I didn't have any clear plan in mind. If, for example, I'm going to do this in the next 5-10 years, I knew it approximately. I was taking courses and then I was a bit bored at the same time. And then, I wanted to try new things. So I was like, okay, what is like what I can do now? So it, like, besides courses, socializing and networking, I thought, well, joining a lab and trying to maybe publish a paper sounds quite awesome. I could give that a try. And that worked out luckily quite well. So, and then one principle that I have, like one philosophy that has helped me a lot is, if, like, whenever I'm unsure, whenever I don't know what to do, what I want to do, I push myself to start moving. Doesn't matter, do something. Like stopping is not an option. That's how I operate. So when I'm not unsure, when I'm not sure what I want to do, I just start doing something. And I mean, you can think of things you want to do, like approximately, you don't have to be like 100% sure. So I would even say if you're like 10-20% sure, go and start doing it. So, because the way it works is you plan, you execute, and then there is a good chance, like 99% chance, that you will fail, which is perfectly okay. And then you go back to ground zero and then you start planning again and you start executing again. So it's like this infinite feedback loop, right? So yeah, don't be afraid of this loop. If you don't push yourself into going to this loop, you just get stuck, right? Which is not good. So eventually, you will succeed, right? So you will find out what you want to do. It's like probably the main reason like people don't know what they want to do. Like from my experience is that they don't try. Like how it's almost not possible to know what you want to do without knowing what opportunities are there. So it's your responsibility to go out there and find those opportunities, right? Explore those opportunities. So if you're doing good with your coursework, if you're able to maintain a good GPA, go and join a lab, go do internships, go do networking. Like networking is a very important aspect. Doesn't matter in which field you are, networking is extremely important. Because it's quite simple, actually, the idea behind networking. So you have aspirations, you want to do something, right? And there is a good chance someone already has done it. So why would you waste your time testing out different things when you can just go and talk to that person and then take a shortcut, right? That will save you lots of time. At least that's how I operated, and it helped me a lot, actually. So building a network is, I at least consider it to be a very important thing. It's people who give you the opportunities. It's people who will tell you the most important information. It's hard to do those, like all those things alone. So talk to people and build a strong network. So just to give you an example of what could a chemical engineering career might look like. I want to go a little bit personal here and share my plan with you. That's what I currently want to do. That's my like 5, 10 years of plan ahead. But I'm 100% sure it's going to change. It would be boring if it doesn't. But this is how I see it approximately. So my eventual goal is to try a startup, right? And a startup is going to be in either renewable energy field or climate change. And then I can see two ways of doing it. As a chemical engineer, I could go and do a PhD or go to industry. And then in both cases, I can go and do a startup. But each option has its pros and cons. For PhD, there like if you go to top, for example, 10 PhD programs like MIT, Stanford, Caltech, right? There is a good chance to turn your projects into startups while doing PhD. That's a possibility. For example, a friend of mine who's doing PhD at Cambridge told me recently that half of the projects in the lab and one like a single lab works on, I know, like tens of projects, and half of them are potentially turning to startups. That's what he told me. So, and the reason is, so first of all, they're top schools, and because of that, almost all of the top companies' attentions are on those schools, right? Like Cambridge, MIT. And so they don't have funding shortage. And then they attract some of the most like brilliant people across the globe. So you don't have the shortage of ideas as well. So you have the money, you have people, you have ideas. Like what else do you need to do a startup, right? Um, so that's why, yeah, like top PhD programs are extremely attractive. I mean, they suit well, quite well for my plan. Um, so yeah, I will try for top PhD programs, and they have to be, and that top is important. Like I don't care about ranking, but I care about those opportunities, and I'm almost convinced that I won't be able to find those opportunities in low-ranking universities. And then personally, for example, KAIST is in top 20 in chemical engineering in the ranking. So it didn't really make sense to me to go below that ranking, right? But that's my personal opinion. So I'm like, if I want to improve, I should aim for top 10 since KAIST is top 20, right? And then yeah, so but then if that doesn't work, there is a good chance it won't work, like because it's extremely competitive. Like a lot of my friends who had even a stronger record than I do couldn't get into top school. So it's quite a possibility. If that's the case, then I'll try to go to industry and then build network, which is hard. Like building network from ground zero is hard. Like if you are surrounded by people who have strong networks, then you can get into their network. But then if you're alone, that's hard. But then still, I guess like I'm determined to give it a try, even if I have to go to industry. So one question I receive very frequently is, I didn't know if I should address this here, but so why bother doing CS, right? If I have this plan of being like hardcore doing chemical engineering, why CS? But then my answer is why not? First of all, it's money. Like if you know coding and if you're in trouble, you're just what is it? A couple of lines of coding away from receiving some extra cash. And that's what I've been doing actually. Like as a chemical engineer, it's hard to start earning before you at least earn your bachelor's degree. It's hard. Like I spent 2 years in the lab and I wasn't paid. But I spent 3 months in this lab and I've been paid relatively well. So yeah, CS is money, like coding is money. And especially if I want to try startup, I will find myself in a hard situation. Because startup takes 5 to 10 years at least to give results, right? So I will need to feed myself, before that. So until I will be able to reach that point. So coding is a good way to do that. And then another advantage that I really want you guys to consider is coding will give you competitive advantage over other chemical engineers when you apply to anywhere actually. Whether it's academia, like graduate schools or industry, as a chemical engineer, if you know coding, you are at an advantage. That's called competitive advantage. And then your starting salary in the industry will also be higher. Like I've come across a lot of companies these days that require chemical engineers to know some basic coding. But then it's your responsibility to find out what kind of coding they require, what kind of software they require. But overall, I guess if you have the ability to switch from one coding language, programming language, from one software to another one in a very quick period of time, very efficiently, that's another competitive advantage. So yeah, I don't see any disadvantage in doing CS as a chemical engineer, except maybe lack of time. So if you can afford it, if you have time, go for it. And then startup in this like 21st century without knowing coding is actually sounds like a bad joke. Because even if as a chemical engineer, if you want to do startup, you will rely a lot. So yeah, that's uh, that's it for my presentation. And thanks guys for listening. And I guess I'll try to answer some questions.
Yep. Thank you so much, Intizar, for your
Yep.
presentation. I mean, like, for everyone, like, Intizar is like one of the exceptional people in CV, I guess. Like, you started like doing lab very, very early. I really noticed that when you were a freshman. So, like, the first question here is you said you joined a lab in your second semester, right?
Yeah.
So, how challenging is it to do that? And how did you keep sane with all the workload you probably had? Or how did you manage your priorities? Because I don't know, freshmen are probably too concerned about their main concern is probably the coursework. I
Yeah,
don't
yeah,
know
yeah.
what's in your case. Is it the same thing or not?
Actually, I would say don't rush. I guess I rushed a little bit. I probably should have waited until at least like my third semester, because as you just noted, like for freshmen, like GPA is important, and I mean GPA is important overall. So, and then not only I joined the lab from my second semester, I also started taking CS courses as well. and I didn't have any background in coding, like literally zero. Like CS 101 was the only, and then I barely passed that course. So I guess I did average. So that was like doubly demanding. So yeah, and I did screw up my GPA in my second semester, but then once I got a hang of how you do things, you know, in the lab, for example, because even setting up a single reaction, I still remember would take me 4 or 5 hours just setting up a single reaction. So imagine doing like lots of coursework for that, and then that's just setting up, and then you do the reaction, and then there's like follow-up procedure. So one reaction would take me days or weeks, and then I was required to do a lot. Um, but then after one semester, so I sacrificed my GPA for that. And the tasks that would take me, for example, 4 or 5 hours would take me only like 15, 20 minutes, you know, in semester. So in my third semester, I did make a comeback in terms of GPA. I got a hang of how you perform, how you operate very efficiently in a lab. So yeah, my advice is don't rush. Like take it slowly. So build a strong, solid GPA in your first year, maybe even 1.5 years. That depends on you. And then start your lab probably in the summer or winter, and then see if you can continue during the semester. Because I joined right when the semester started, and that was that was an additional burden.
Okay, thank you for the answer. Oh, for everyone, if you have more like additional questions, don't forget to ask the questions in the link that I gave in the chat.
Yeah.
But like right now, that was the only question. But
Mhm.
I think I would like to add a little bit of my perspective of being like a CBE student.
That would be
Because,
awesome.
yeah,
Yeah. Mhm.
because I would say the research that probably is done is like, let's say the coursework is more about, you know, the classic chemical engineer. You study like fluid mechanics, you study heat and mass transfer, and then thermodynamics, a lot of math, a lot of math and physics.
Yeah.
But then let's say I'm doing the research which completely does not require any of those. So it also like gave me a hard time because I have to study like both.
Yeah.
That's, I would say that's a little bit drawback of the CB, because like I was expecting to study like, let's say, the classical chemical engineering, and then
Mhm.
I thought that research would have help me to understand that, but it turns out I think many research lab, they don't really have much to do with that, or just like a couple of stuff related to that,
Yeah, it's quite
right?
rare actually, and uh, like in fact, what is like ironic is there is only one professor who does actual chemical engineering and chemical engineering department.
Yes, yes, yes. I
Yeah.
think it's Professor J, right? I think
I
he
forgot his name, but as far as I know,
process
he's the.
process process control, I think. I'm not
Oh, I
really
think we're talking about different people.
okay.
He's the chair of the department,
Oh,
so
oh, okay.
he does like proper reactor design. So he's the only one. Like other 32 professors in the department, they do other stuff.
Yeah, either mainly focus on like nanomaterials, or like
Bio,
biochemical engineering, which has nothing
renewable
to do,
energy.
yeah, which has nothing to do with the classical chemical engineering.
Yeah. But I said like those courses are important. Yeah, like I guess primarily in a classical chemical engineering sense, but even when you go to academia, like apply for graduate schools, as far as I know, they will be a huge plus.
Yeah,
They definitely were when I applied for Columbia for an internship, and like you got offer from a very top school, so maybe you could add your perspective on this in terms of application.
like for me, I think in my case, it's because of my letter. I would personally say that, not really because my grade, but I think
Mhm.
it's like more of the help from my professor. Yeah.
Oh yeah, like letters are extremely important. Yeah, like, so one letter got you into a very top graduate school. Yeah, that's quite amazing.
Yeah, and I don't know what else to talk about chemical engineering, but I personally think graduating from like CBE Department of Guys as a bachelor is enough to like get you into like, let's say, top industries if you want to work on industries. That's, I don't know, that's just my personal opinion.
Yeah, you can definitely get accepted. But then again, depends on a position and I guess how much experience
Yeah, that
the
matters.
recruiters are
Yeah.
expecting, and then depends if you're okay with the salary they provide you as a undergrad. So
Because I've noticed like sort of trend in CB department that many people, they just continue for masters once they graduate. If they don't
yeah,
have CS background, if they do have CS background, working is not really a problem for them. I'm just saying
yeah,
that's sort of a fact.
totally, yeah. And then there is like this interesting combination actually, which I want to give try if I have time, which is chemical engineering and data science. Data science it's also an interesting combination. It's ML, AI, and a little bit of coding. So nowadays, like for example, data science became like, hyped in the last 5 6 years. And so what companies were doing were they were recruiting data scientists and they were teaching the product they were producing. For example, a chemical company would recruit a data scientist and then teach them chemistry. So nowadays they're realizing that's not an efficient way of doing it. So what is more efficient is to uh, hire a chemical engineer who knows data science, and they are paying a lot. So, like data scientists who specialize in one field are receiving even more than like the average data scientist. So, and the field on like by itself, on average, as far as I know, people start earning from 150,000 per year in the US, which is an extremely good amount. Like even like software developers, juniors at Google don't receive that much. So
Wait, I think it's already 45 minutes. I think for the participants, if you have like any other questions, I'll wait for 2 more minutes. Otherwise, we'll just end the session today. Okay.
and I guess it like speaking through the mic is also an option, right?
Oh yeah, yeah. Or you can
Well,
also like ask your question directly here.
we're a couple of people, so guys, go ahead if you have questions.
I'd like to briefly review of your like presentation. I think it's important for the freshmen to know that there is not many chemistry involved in CBE department. That's one
Yeah,
thing that everyone like you should like really know. It's
yeah, exactly.
more of like math and physics.
Yep.
Yeah, I studied physics like more than I anticipated, I think. Yeah, that's really important to note.
Yeah, especially if you start taking advanced courses, like there is no a single trace of chemistry almost
No,
in majority of the advanced courses.
it's either physics, bio, or yeah, I think it's either physics or a little bit of bio.
Yeah, but like personally, I'm not a physics or math or science guy, but what got me hooked to chemical engineering is that you use physics and math directly for applications, and you can see them directly. So the textbook you're reading, it will clearly show you where you can use those complicated equations
True.
and what people have already discovered or produced using those equations. There is like direct correlation, which is quite attractive.
That's true. That's true. I do agree. Has it been 2 minutes? Okay, it's been 2 minutes, I guess. So because there's no questions from the participants, I think we'll conclude the this afternoon's session. So I'd like to thank Intizar. Thank you so much for preparing the presentations and also for explaining the about CBE and its prospects after graduation. And also, I'd like to thank you, the participants, for joining us today's afternoon. Thank you very much. I
Thanks
hope
for
you
having
guys have a great Sunday. Bye bye.
me.